Thank you for the introduction. My name is Dr. Petr Šimunek, and dear colleagues, let me to present a paper dealing with a comprehensive evaluation of building of construction. I will start my presentation just one moment. So please, can you see the presentation? I hope yes. So this described evaluation approach was developed with the cooperation with the Technical University in Brno and the Institute of Applied Mechanics, Brno. Okay. So the main objective of this evaluation process was to allow selective maintenance planning, design of measures and maintenance based on the current state, determination of the level of risk of damage, considering possible economic, safety, and other impacts. This idea was actually taken from the functional evaluation, which is in process, and it deals with the machine parts of the nuclear power plant in the Czech Republic. So now I will try to introduce step-by-step evaluation process. So first of all, we have to make a selection of a structure for comprehensive evaluation. The developed tool is relatively large scale, so it's rather suitable for important and large constructions. These are, for example, buildings or nuclear power plants, etc. The evaluation is performed within an expert team, so we have to build an expert team which must include all necessary specializations. The main part of the evaluation is the processing of a structure information. So a summary and analysis of all available design information is very, very important. Next, the evaluation can focus on more aspects. In our case, we started actually with a static capability of the structure. The structure is not evaluated as a whole, not as a whole, but actually individual structure parts are evaluated. Therefore, the structure must be divided to the components. Depending on the type of construction, sets of evaluation criteria are compiled. These areas cover the entire life cycle of the structure. And at the beginning, the method of design, project documentation, method and quality of construction, materials, etc. are evaluated. Furthermore, the current state of the building, the method of monitoring, maintenance, and operation are evaluated. An important part is also the assessment of the impact of damage to individual parts with regard to the economy of operation and the safety and possibly other criteria. The evaluation of the criteria is performed using a scale depending on how the requirements of the criterion are met. Specifically, we used a scale of 1 to 5 degree what was used. Based on the evaluation criteria, indexes are calculated. I will explain afterwards the meaning of the indexes. These indexes determine the current state of the building, the risk of the damage, and the economic safety and the other impacts of a component damage. The risk matrix, we use also the risk matrix for the expression of the economic and the safety impacts to the whole evaluation. The final assessment is performed on the basis of a combination of information on the risk of economic and safety consequences, the condition of the building, and an estimate of the probability of the failure. Based on the evaluation, the design and implementation of measures is performed. And at the end, the evaluation is carried out periodically according to plan or on the basis of new requirements information, and this is done in periods. So here you can see the overall the scheme from the criteria rating to the index computation, condition and risk rate with the help of the risk metrics, and we will get a final risk rate and the structure conditions. We also can consider the weight of the criteria, and periodic evaluation is done for whole comprehensive evaluation. Well, the areas of available evaluated informations are indicated in light brown. Based on this information, the indexes are determined. They are planning, designing, building up. Then the other areas is analysis and verifications, service observation, maintenance and monitoring, operation and operation effect. Also, the consequence of the damage with respect to the safety and the consequence of the damage with respect to the economy of the operation. The damage potential, I mean the index of the damage potential expresses the propensity, or also it could be estimated as a probability of failure, but it's just the estimation. It's not the calculated probability. Also, we will then get from the input information index of the condition and the present structure condition. The safety and economic risk rates, it's here and here. And with the help of likelihood, we can get a safety and economy risk rate with the using of metrics, risk metrics. So now we have an index of the conditions, index of a damage potential, and safety and economic risk rates. Index scale, we use for index scale these levels from A to the D, and for the A is an excellent condition of the structure component, and on the other hand, the D is insufficient condition, the worst one. And under the knowledge of these all things, the final assessment is performed using a combination of damage potential, safety risk rate, economic risk rate, index of the condition, and the final evaluation is done with the combination of these four information parts. And this is done for each component. It's not done for a whole structure as one building. So the evaluation, as I said, is performed for each element separately. So care or repairs and so on can be directed primarily to the important elements. So we know what elements, what parts are necessary to repair or take care just now, and what parts are in good condition. So here is an example how we can make a decomposition of a structure, and from the whole structure we will divide it to the walls, as here. Each wall has itself a number. Also, it's the same with the foundations and the ceilings. For each member, each each walls we define the material, the requirements, the environment, and so on. So a lot of informations. For each member I mentioned above, we assemble a set of evaluation criteria. The sets are at the areas of planning, designing, building up, analysis, verification, operation effect, service observation, maintenance and monitoring, and safety aspects and economy aspects. So at each of these groups, there are next a lot of aspects for checking and evaluations. So for each these parts, we have prepared a form in a questions, and we for all these questions we reply the criterion rating. So the first, it's not necessary no measure proposals. So it's a negligible. The condition of the structure is very good. On the other hand, when we will evaluate the criteria with the 5, the structure is in emergency condition, it's very poor. Of course, quite often we have no information about the requested part, so we have to consider also that the information about the structure is missing. Here we can see the way how we can calculate the index value. Actually, we have the rating, what was mentioned above. It's an A. I is a criterion weight, so we can use the weight to distinguish the weight between the criterions, and K is a maximum possible numerical value. So this is a value of the index. And for this whole proposal evaluation design procedure was done to get a software database where are all information inside. I mean the name of the part, material, surface, environment, dimensions, and a lot of the others information, also the schemes, and possibly could be an verifications and so on. All of these informations are here in the database. And also the mathematical core is inside, and based on the evaluation, the management decisions could be made. And as I said before, the final result of this is here, and from the software, from this database, this is the output, and we can distinguish the members, and we can see what members are in good conditions and what members are in poor conditions, and we can direct design and make the measurements. We had some ideas how to work with the risk, and we do not use the term risk in the evaluation, but the risk rate, because usually the risk is defined as a likelihood by a consequence. And therefore, we will get the surface in the ground floor. The values of the risk could be expressed with this chart. And for this risk expression is appropriate this risk matrix. Like can we see here the high risk and low risk, but actually this matrix is not as usual as you can see and you can maybe know. So this is the most used risk matrix, and we use also the risk matrix, but we can't now say that this is a risk, but we call it a risk rate. So the risk rate now is not like likelihood a consequence, but we have a little bit different numbers. So this equation doesn't work anymore. So if we have no problem to express is a qualitative, but once we want to get the quantitative outputs, we have to use a different approach than this one. And one of the possibility approach, I'm sorry, is this one. We can use an fuzzy logic tools, and we proposed this approach to determine the qualitative value of the risk level from the risk matrix. So then we can use the inputs data. We can use these membership functions for input parts, and we will get a result as the surface. So we will get the appropriate also the numerical outputs from the risk metrics. It was a last part of my explanation and my paper. And now please let me to make a conclusion. So I would like to summarize the functional tool for comprehensive evaluation of major structures has been developed. We also started a pilot project for power plant in Dukovany. Unfortunately, the COVID crisis delayed the implementation now. So thank you for your attention, and thank you for the time here.